Assalamualaikum and good day. We'd like to present our new mini project, which is nuclear cooling system for the subject system integration design. Our mini project consists 9 networks overall. For the network 1, we use template TF100 for the CPU to simulate the program into the factory I/O. For the CPU TF100, we offset the analog input address to 40 and output analog address to 60. For the network 2 is the filling valve process, which is we include the start button for the filling valve and also start and stop button of the HMI button. In network 3, we include stop button for the filling valve. When the user press the stop button, the process of the filling valve will end. In the network 4, for the set point of the filling valve, when user enter any number or value, that number will display at the setting point and also will read in the analog output. For network 5 is the discharging valve process that include start and stop button for discharging process. In network 6, we use stop discharging valve that when it's pressed, it will open the level and it's reset to 0. For network 7 is the set point of discharging valve. When the user enter any number or insert any number, that number will display at the set point discharging valve and it will read at the analog output. The last network is the reading the level tank. When the user enter any number for the filling valve process and or discharging valve process, that number will display at the tank level, so we read at the analog output. This is the HMI screen of our mini project that includes filling valve control process and discharging valve control process. For filling valve control process, when the user press start button, the filling valve control process will begin. When the user enter any number, the water will fill in the tank to the maximized number, that is 10. The user need to enter 0 number to stop the water from filling in the tank. When the user press the stop button, the process of the filling valve control will stop. Then for discharging valve control process, when the user press start button, the discharging valve control process will begin and user need to enter any number to discharge the water from the tank. When the user press the stop button, the discharging valve control process will end.
Hi, so for today, I will cover a topic on how my system works by using a SCADA. As we know that, we utilize SCADA is to improve this project system since this is capable of creating a smart maintenance regime and lowering downtime, achieving a more connected operating and tracking the next step towards Industry 4.0. The first screen of NCC Advanced is to controlling and monitoring. As you can see, this is our first screen and this is our second screen for monitoring. Back to our first main screen. As you can see, this is a part for data recording and it is save all the existing data in the Excel. And this section is about to control the valve has a start and stop button and the indicator. The same is true for the control discharging valve. If any button either from the start of filling or start of charging, the valve will automatically turn to green as well. Each input supply by the tank bar during filling or discharging will read the value in real time. If we click this tank, we will be sent to a screen 2 where the data is displayed in real time in the tank through the trend. By using a screen 2, it will show us how the data will be displayed by trend. At the meantime, we also create a report. We may also create a report based on a quick reading to generate a formula. The system is through a simulation of factory I/O and ETL portal usage. Next, we'll be moving on to HMI alarm on how HMI alarm works. As you can see, on the discrete alarm, I made the ID one where starting alarm, filling valve, and the alarm text will be the filling valve is started. We're moving on to the analog alarms where I create 4 conditions on the alarm there is 9 higher 9, 8 higher, 2 lower and 1 lower. On the alarm class, as you can see, there is 2 errors and 2 warnings. When the critical height level reaches to 9, it will automatically display an error. When the numbers of tanks is decreased to 8 and it will automatically shows a high level. On behalf a low level warning, on the limit to it will pop up a warning level, and for the critical low level, when it comes to 1, it will be an error for the system.
Hello, Assalamualaikum. As you can see here, this is overview of our mini project by using a SCADA system. As you can see here, once I turn on WinCC, I was able to make it functionally by testing on the main OB. This is it, for example, when I hit the start button, the output indicator will turn green and also the valve will turn on. Another one is when I click stop, it will automatically stop the operation and the valve will continue to off. For simulation, we use the tank as an illustration of how the water is stored and removed for the purpose of nuclear reactor safety through the use SCADA in this system. The first thing we have to do is to record all the record system by pressing a start on the logging. Next, as we can see here, in the alarm view, we can see the system display the reading of the tank is in a warning state and error. It will return to normal if the number of the water in the tank has exceeded on 2. So, fortunately, to turn on the filling valve, we need to press the start button and the valve goes green, and I enter inputs number until 1 to 10 where we can control the speed water flowing in the tank. For example, I enter number 5 and I hit enter. As we can see here, the water from the tank is getting higher. This can be proved by turning on the log off tag. It shows that the tank 1 filling valve will be reached by 5.0 input. It will stop by adding a 0 on input number. We are using a non-automatical closing system, and I will stop the operation for filling. Then we go to the start discharging. So right now, the level meter shows 4.2. Same goes to the WinCC Runtime Advanced, where it shows the current value of input water in the tank. This is real-time information. At the meantime, we also can see the trend of the water by clicking the tank. It shows that the numbers is 4.2. On my left, I set this is for percent, and on the left is 0 to 10. So we're going back to home. So right now, I just need to add number 10 on input number. as you can see, the water inside the tank is decreasing. Same goes to the reading on the trend. So we're going back to our main screen. In few cases, if the water in the tank is too high, and I will stop. I adding a 10 in my system. We can see the water flows in the tank is much faster than the previous number. Okay, hi. Let's move on a few conditions. If I start the filling valve on and I add number 10 as input, we can see the fill valve reach a maximum number, and we can see the filling valve is getting higher. Same goes the reading input, where the number is getting increasing from 0 and now almost 50. We go back to our main screen. Right now, you can see there is a message on the screen where it shows the numbers in the critical level where it reached the maximum numbers. So now, that's all from me. Thank you. Okay, now I will show you on the data logging and tank logging. This is a record where all the information of start and stop of filling and discharging works. You can simply click tank logging. Okay, now we can see all the operation, for example, set point of filling valve, the valve value, the validity, and the time in a millisecond. So that's all for me. Thank you.